All right, as the title of the presentation says, tips and best practices for modeling and analyzing connections. Let's highlight these words, modeling and analyzing, okay? So we'll use the finite element method to analyze the connections here, okay? But I would like to show you how exactly some tips to model and then to analyze, okay? We have different situations, different moments of our workflow here. So I've divided the presentation in 4 main parts. We'll have a brief introduction about the system that we have here. Then we have 3 tips related to the modeling of these elements, the modeling of the connections. Then we have 2 tips related to the analysis, and we'll finish with an example of a workflow that I can suggest to you in this case if you work with a team with more than 2 professionals working in a same structure. Okay, to start, let's talk a little bit about OpenSees. Okay, OpenSees is the acronym to Open System for Earthquake Engineering Simulation. Okay, it's an object-oriented software framework that was developed between 1997 to 2007 in the University of California in Berkeley. Okay, so this framework allows users to create finite element applications. Okay, these applications that they are usually used to simulate the response of structural systems subjected to earthquakes. Okay, so we will be looking how this framework is integrated in the tool that I will be showing to you today. So it's important to you to understand what it means, what is OpenSees. So this is just a brief introduction about this framework, this engine that is very powerful and very famous in our sector. Okay, the second software, the second tool that we have here today that we'll be talking a lot about it today, it's called CYPE Connect. Okay, CYPE Connect, it's a tool for modeling and analyzing the connections between elements of steel and timber structures. Okay, so it's a software that actually integrates the OpenSees framework inside of it. Okay, so CYPE Connect, it's able to import BIM models, analytical models from other tools where the structures were previously analyzed, and was developed by CYPE in 2021. Okay, so we have here 2 to 3 years of this software, but it's very popular between our users. We have users around the globe, all around the globe, using this software. It's translated to different languages, and have 39 different codes just when we are talking about steel members. If we consider also the reinforced concrete anchors, the anchors that are created in reinforced concrete, we have more than 50 different codes that can be checked when we analyze the structure analyze the connection using this tool. Okay, so here, in addition to the modeling and analysis, we can check the code. We can select the code and compare the results of the analysis with the parameters of the code, and have we can check if the connection is correct or not. And then if we want, we can extend our workflow and export these connections to another tool to then manufacture the structure. Okay, so our idea here at CYPE is to connect CYPE Connect with OpenSees. So then it could be an easy way to use the power of OpenSees, the power of the OpenSees engine, with the aspect, the environment, the menus that we have in the CYPE ecosystem, that is very easy to understand. It's very easy to learn, because our idea was to promote the use of the finite element method to any user, although this user don't know too much about the finite element method. So our idea is to have this system to introduce the node here, the connection here, with minimal or no user intervention. Use the OpenSees the easiest way possible. Add the data to the framework, analyze it, and then get the results to compare with the code and finish the project. Okay. If you want to know a little bit more how these tools are integrated, how OpenSees was integrated at CYPE Connect, I'm leaving in the chat below the link of the calculation report of CYPE Connect, where you can see how the plates, the bolts, the welds were were set in the CYPE Connect. You can also find more information for advanced users that want to change parameters that are related to the when the OpenSees starts running. Okay, so you can find the calculation report in the chat below. I'll ask also to our team to share on LinkedIn, in the live LinkedIn, the LinkedIn live, the same link. Okay, and just to finish the introduction before we start working with the software, let me tell you that in the same way that we can connect OpenSees with CYPE Connect, we can then also connect CYPE Connect with StruBIM Steel. That is another software that we have. And connecting CYPE Connect with StruBIM Steel adds some features, adds some things that can be useful for us when we are modeling some connections. Today I've selected 3 tips related to modeling the connection. One of them is combining CYPE Connect and StruBIM Steel. Okay, so let's go. Let's start with our point number 2. Let's see the 3 tips related to connection modeling. Okay, the first one, let me open here CYPE Connect. This is CYPE Connect. Let's go to the main menu. This is the main interface of CYPE Connect. I have here a list of connections. Okay, and actually here we have just 2 connections, but I've created the same connection sometimes considering different scenarios or different moments. Okay, just for educational purposes, let's say. Okay, the first one is this connection here. Okay, I will use this connection to show you how you can use the planes, the operations to create planes, in a smart way to then optimize the modeling phase, and then use the connection, a same connection that was created in a first moment to using a second or a third or another node that is similar. Okay, so my idea here is show you how to use the planes in the correct way. Okay, so this raw node, or this node that is here, we can see that we have some clashes here, this gap here. So this is not a connection, it's just the node that was created. Okay, and actually the situation that we want is this one here. Here we can see that the flanges and the web of these sections were welded. We have here the sections in the correct size. They were cut, they were standard. Okay, and we have the same situation again here, although you cannot see the difference, the geometrical difference between the right and the wrong situation. I'm added this name here to tell to you there's a right way and there's a wrong way to create this connection. Okay, so let's inspect a little bit both of them to understand what is happening here, how this connection was created, which operations were selected, and how they were defined, to understand why one of these is wrong. Okay, so I will start with this wrong one here. So let me open the editors, the connection editor. Okay, and you see that there is a very easy to create connection. Okay, so here we have a list of operations. Let's deactivate everything here to understand which steps we had here. Okay, so the first scenario was like this with some clashes here. Then we started creating a plane here. We'll see a little bit more about this plane in a while. Then some adjustments to DB1 to the plane were done. The same situation to B3, so now we don't have clashes, and now we must weld the 3 parts that we have here, this one, okay, and also this one, using 3 weld operations. Okay, very easy to model connection. Okay, and it seems everything is correct here. Okay, the point is, let's accept it. Okay, and let's change some parameters here in the node. Okay, so let's imagine the node, instead of having 30 degrees of the angle of 30 degrees here, we had like, I don't know, minus 60. Okay, something like this. Let's see what happened here. Let's go to the editor here. You see that some problems can happen here. Okay, if we go here, we zoom in, we'll see that something wrong is here. This is probably impossible to weld. maybe we have problems here. I don't know, maybe according to the angle that we have, we could have a better situation, but this is not the best way to connect. So to do that, we should change the angle here to 60 again, okay, or sorry, in this case, minus 60, okay, trying to change the parameter of the angle according to the angle of the bar, or the angle that of the bar that reached the node as we saw before. So this is the problem here, okay? We defined a plane that was a manual, a plane that was defined manually. So the parameters of this plane were not they were not automatic. So when we changed the angle of B1, the plane remained in the same position with 30 degrees, creating this little situation here that is not correct, okay? So the correct way to do that, let me show you the other one. It's quite similar, okay? The correct way is, it's use the same operations, but set the operation that creates the plane in a different way. So we have the same operations here, but in this option, we do not use the angles, which allows us to define the values here. We use the option that is the bisector, okay? And the bisector between B1 and B3 in this case. So if now we change the angle of B1 or B2, the angle will always be the bisector between both of them, and then the adjustments, they will follow the plane, and everything is gonna be okay. Okay, so let's accept that, the right one. Let's change again the node here to have an idea about what will happen. Let's change the value here. I think we use it 60, if I remember. Let's accept. Let's go to the edition option, and let's see what happens here. You see that in this case, no problem. Perfect, okay? Everything is correct here because the bisector between both of them is possible here. So yeah, with this option, you have a more, how can I say, useful connection, okay? The idea here is export this connection to the connection library and then use this connection in different nodes. So with this second option that I showed before, with this tip about using the different options to create planes and not always the manual option, will allow you to use these connections in more situation. And then if you have, it's gonna optimize your time because you don't, we will not need to calculate this angle and define it manually for each connection that you have in your structure, okay? All right, so that was the tip number one. So let's keep going. We have 3 tips for modeling. And to the second one, I've selected here these 3 situations, okay? Let's imagine that we have this first situation here, a node that is being reached in a column in this case, and we wanna do something like this, okay? Very easy to do, okay? If we inspect this connection, okay, you see that we have here just some simple operations, just 3 operations. One of them to create the stiffeners, okay? Then another one to create this plate, okay? This operation was called frontal 1, and then some bolts to connect the plate to the column, okay? Just 3 operations, okay? Let's come back here to our scenarios, but let's imagine that then we have this situation, okay? We have a same situation, but with 2 beams, okay? Let's imagine we wanna get the information from this situation 1 to create the situation 2. So how we can use this information from the situation 1 to then model the situation 2? It's very easy. So I'll open the situation number 1, and I'll export this list of operations to my library, okay? So with the shift button of our keyboards, we can select all the list, use this little button here, or also use this button here to export this list. I'll call it C001, for example, C001 90 degrees, okay? 001 90 degrees, just to add here a name for that, okay? And then I will close the situation 1, I'll go to the situation 2, I'll open the connection editor, okay? And here in the connection editor, I will now import from the library using this button here, the C001, let's see, 001 90 degrees, okay? When I try to import, the software will tell us that some parts of our the connection that we have in our library must be assigned to the connection, the elements that we have in our node. For example, here in the left side, the library, my library, the P, the column is called P. In my node, it's also P. So here I will maintain P with P. And here, the name of the bar that we have that is connected to the plate is called B. So the B I will assign to the B1. Could be also to B2. I will start assigning the B of my library to the B1 of my node. Okay, so let's accept and let's see what happens here. So here, part of our connection is already solved using the operations that were exported before. Now, something that is interesting that I can do is select, for example, just these options here that are the plates and also the bolts, but without selecting the stiffeners, because the stiffener, it's already correct. Okay, so select just these guys here and export, and I'll call it C002. Also 9 degrees, okay? Yes, you can see here in the screen that the stiffeners were not exported here, okay, in the previews before we export. And now I will import again, okay? It's important to click here in the last operation to set the position of the operations that will be imported. So let's import again. I'll look for C002. And here the 0002, and now it's important to maintain this little button here, keep previously defined operations. So with this option we can merge both connections, and now I will rotate it in this direction. Okay, the B1 of the other project, it was already created, so now the B2 is missing, so P is gonna be P, B1 it's actually gonna be B2. Okay, and let's accept, and let's see what happened here. We almost have our connection here. Probably one of these bolts it's not finished, so let's take a look here. This bolt, maybe now it's defined to the top flange of the column. Let's change to the bottom, and it's already connected. Okay, so as you saw, just with some little steps, with some little clicks, without adding any element, without adding any new element, we can create the situation 2 departing from the situation 1. And of course, now we can also export everything to the library and have a second connection based in the first one. Okay, so this was my tip number 2. This is the partial way to export operations to the library. So remember, you don't have to export everything here. You can export just part of the list of operations to then use it in other connections that are similar to the connection that you have. All right, talking about merging connections, let me jump to StruBIM Steel to show you how you can use both softwares, StruBIM Steel and CYPE Connect, to then merge connections. Okay, let's look for a connection here. For example, this guy. Okay, let's see what is happening here in this node. In this node, the way that this connection was, the way of this connection was modeled. Actually, it was modeled. There are 2 connections that were modeled near. So we have one connection that is connecting probably this yellow member to this column, and another connection that is the other elements here. Okay, actually, if we open here and inspect it, we can take a look how these models were created. Okay, so we have one situation that is this situation here, okay, without the diagonal reaching the column here, and we have a second situation that is this this other pyramid here, the purple pyramid. That means that we have a connection here that is just the diagonal reaching the column and the beam. Okay, let's imagine we want to merge both of them and create just a unique connection here, because then we want to analyze this connection in just one connection. Okay, how can we do that? The first thing that I will do, it's gonna export these connections to my library. So I'll open the first one. I'll select everything here, okay? I'll export it. I'll call it connection con 001 part 1. Part 1. Let's imagine this is part 1. Okay. And I will close this connection. And I'll do the same with the other. I'll select all the operations that I have here. Con 002 part 2. Okay. And I'll also close it here. Then I'll delete these guys to have something a little bit cleaner. You see that when I delete the symbols here, the parameter symbols, the connections will be deleted. So we'll have the node in the situation that was imported to the software. Okay. So then I will use this button to create a new connection. And to create this new connection, I will select this element. Let's get a zoom out here. Also this element, the column, and this yellow element. Okay, all of them. With my mouse, with the right button, I can click and confirm that the node was created, and now we will start creating our connection. Okay, from here, I will start importing the part 1. So let's look for part 1. Let's see what we have here. We have here connection con 001 part 1. Okay, so let's import it. Let's see what is happening here. In the library, we have this guide with this situation, and our node is like this. V1 is V2, V1 is V2, V1 is V2, V2 is V1, P1 is P1, and V3 is V3. So it's perfect. So let's accept. And part of our connection is already done. So now let's do the same with the other part. Okay. So let's import the part 002. Oh, it was part 2, sorry. Part 2 con 002 part 2. And let's use this option again. And let's see what's happened here. So yeah, here we have this situation. V2 must be V4, V2, V4. P1 is P1, and V1 is V1. And here we have our correction, our connection with both connections, the previous connections merged in a unique list. Okay, so we have a unique list of operations here. If you want, we can export as a complete connection, for example, okay, to then use in other parts of our model. Okay, so this is a very easy way to merge connections when we are using StruBIM Steel with CYPE Connect. Okay, so by clicking using this option here, you can select the elements that will be part of the connection you are trying to model, and then you can also import operations from other similar connections to merge them and create a unique connection like this. Okay. Cool. So yeah, related to modeling the connections, we had these 3 tips. So let's jump to, let's see what we have in our script. Analyzing connections. 2 tips for analyzing connections. The first one that I would like to show you is related to the definition of operations. Okay, let me show you here this node, for example. I think it's an interesting node. Okay, this node is it's a little bit complex, not too much, but yeah, we have here some interesting elements. And once the model is finished, okay, the idea here is to jump from the model tab to the analysis tab. Okay, in the analysis tab, we have different things that we can set here. Okay, but I think the most important part before we start analyzing is defining the load cases of our project. Okay, as you can see here, just to this node, I have here 4 combinations, 4 load cases according to a specific hypothesis, some hypothesis that I had in my previous analysis when I was analyzing the structure itself. So these are the load cases that I have just for this node. And for each one of these load cases, then I must add loads for each bar. Okay, so for example here, I must add for each load case some normal forces, some axial forces, some shears, some momentums in different directions. Okay, for each one of the elements here. the software was made, it was developed in a way that you can create your own load cases here. For example, if I create my load case here, and then go to the loads and add manually these numbers here to analyze to add the loads to the node according here, for example, this criteria that you can see here in this little picture. Okay, you can do that. Okay, but where is my tip here? If you use the complete ecosystem of tools developed by CYPE, if you use a tool to analyze the structure before you analyze just the connections at CYPE Connect, if you use one of our tools to analyze the structure, you can import from the other softwares that we have in our suite these loads and these load cases. And considering that in a project you can have maybe 100 of connections, this saves a lot of time. And it's more, you have more precision when you import and you don't have to manipulate this data. Okay, so my tip here is use this button here, generate the loads and the load cases from the BIM model. Okay, and here you can set how these loads will be imported from the BIM model. And if you already use it, CYPE or CYPE 3D, that are our softwares, you can import that loads from the structural model, and you don't have to introduce these loads again. Okay, let me show you just another example to show you how these loads change. For example, this little node here that is quite simple. Let's take a look on that. Okay, here you see that the analysis tab have other situations. Okay, let's take a look here. The load cases are different here. The loads here maybe are different. And if you don't import it from CYPE 3D or CYPE Connect, you must enter that. Okay, so let's press the analyze button, the stress strain analysis, and let's let OpenSees work a little bit here. So this is the point that I said before. We've created all this interface to model the connection, and here actually we are just given to OpenSees analyze to us to in this case analyze the stress, all the parameters of this connection, and the results that will be exported, or the results from OpenSees will be then compared with the parameters or the limits of a code that we can select before we start analyzing. Okay, as you can see here, just in some seconds we analyzed the connection. We can see the results here. Okay, so we can see that the bolts have a little bit more they have the maximum demand capacity radio a little bit bigger, so between 60 and 80% of the capacity, but the plates, the welds, and also the sections, they are very safe because they are between 0 and 20%. Okay, the point is that we have here some failed checks that are related to other situation that is related to the code that was selected, but I will cover this kind of situation in a second example in a while. Okay, just showing here some results. The von Mises stress in this case, we can see here. Okay, the results are here. We can see some concentration here. We can see the results for each one of the load cases. Okay, we can also see the equivalent von Mises deformation here. Okay, and we can also see the displacements of this element to the load case that is selected. Okay, so yes, if here we add a scale, we can have an idea how this connection is working, what's the behavior of this connection. Okay, we can also analyze the calculate the rotational stiffness and also the local buckling of the sections if we use these options, and they are also they will also run using the OpenSees framework. Okay, so my tip here was very simple. Use CYPE or CYPE 3D to calculate the structure and then export it to CYPE Connect or StruBIM Steel to have all the load cases and loads already defined here in the software. Okay, more precision, less time. So let's go to the second tip related to analysis of structures. So I'm using here CYPE Connect for a wooden structure, a very simple wooden structure, just to show you one example that is wooden timber structure. And actually here we actually don't have to make too many loads. The loads here are just the self-wake, just some small loads in this structure. But yeah, I've created this connection here. Let's edit this connection. It's a very simple connection created by a plate and some bolts. So you have just some adjustments, plates and bolts. Very simple connection here. Okay, if I open the analysis tab here, you see that the connections are, the loads, sorry, they are very small. Okay, very small loads here. Probably I will not have any problem regarding to the loads if I analyze this connection. Okay, let's take a look. This was generated from the BIM model. Okay, but let's take a look in what happens here. Okay, although we don't have a high load here. Okay, let's see what the software will tell to us, because sometimes when we are designing a connection, not everything is strained or is stressed. Sometimes there are some parameters or criteria that we must check that are based on the codes that we are using. There are sometimes some it's difficult to analyze it. Okay, so here you can see that everything is green. Okay, the bolts and also the plate. So between 0 and 20% of the capacity, perfect. It seems to be safe, but we can see here that some of the checks have not been verified. And what is happening here? Why some checks were not verified if it's everything on green here? Because probably we'll have here some checks, some code checks that are red. Okay, actually if we click here, we can only show the failed checks. Okay, and if I open this page, I can see that according to this probably this is the Euro code, there was a distance here that should be 80, and we have here 60 millimeters, and this criteria was not checked. Okay, so my tip here is, although in some situations you have small forces, you have small loads, you can use the software to check this manufacturing criteria that that's in some situations it's complex to analyze manually because there are too many details. Okay, so this is the tip, and to do that you can change, if you want, the minimum absolute value forces and moments that are imported from the BIM model, because sometimes I think the default value here is 2 kilonewtons and 2 kilonewtons meter. So sometimes you have 0 loads here, and then you cannot analyze the connection. But my tip is, if you know that is a small load, change for a smaller value here, analyze it, because some of these code checks could be important, and the software can help you to identify if you are missing something when you are designing your connection. Okay, so this is the second tip related to analysis that I was wanting to share with you today. Remembering that you always can open the design options here if you are an advanced user of OpenSees. If you are an expert user, you can define here some parameters to then change these parameters here. You can set the size of the element. You can set the length to calculate the average stresses in welds. Okay, there are some parameters for advanced users that you can also change here. If you are starting, you want to model like this and analyze with OpenSees without need to understand everything about OpenSees, just maintain the default values that we have in the software, and jump to the strain analysis and have your reports with the results. Okay, cool. Yes, let's go back to our presentation here. The last parties and workflow that I said before. Let me open the presentation here, because this workflow, let's imagine it's just a suggestion. Okay, let's imagine we have a team with more than one engineer, like 4, 5, 6 engineers working in a structure. So in a first step, we will probably have the step to structural design. Okay, so we will define the model of our structure. We will set all the momentums, the shears. We will analyze we'll define all the conditions of our structure, analyze according to the wind codes, the seismic codes. We'll have the final sections of each element, the materials that we want. And let's imagine that this is the engineer number one that is doing that. If you are using our software, you can do that at CYPE 3D or CYPE CAD, as I said before. This is not the subject of this presentation, but if you look for that in our website or ask in the chat, I'm sure you can receive more information about the softwares too. In a second moment, let's imagine that this structure must be designed, and we have here different connections. Okay, with CYPE Connect, we can create lists of connections. So we can, for example, assign one type of connection to one engineer, then a second type of connection to a second engineer, and another type of connection to a third engineer. Okay, so here we can use the library of connections to split the work between different professionals that are modeling and analyzing the connections, okay, at the same time. Okay, so this is a workflow that you can do. You just need to have 3 licenses of CYPE Connect, for example, but then you can use the library, because the library exports elements. You can import and export the connections to one project to another. So one possible workflow would be working with different engineers to design the connections. Okay, and just to finish that, as we have been looking a little bit about StruBIM Steel, you can also go a little bit further and then export these connections to StruBIM Steel, because the StruBIM Steels also reads the connections developed at CYPE Connect. And then, for example, let's imagine engineer number 5 could generate the structural detailing that will be exported to DSTV, STEP, or any other format to then manufacture this structure. Okay, so as one of the main topics was have a tip about a possible workflow, I've chosen this one that could be made by different engineers in the same project using, in this case, for example, CYPE CAD or CYPE 3D, then using CYPE Connect for dividing in different lists, and now StruBIM Steel to finish the details. Okay, remembering here that at CYPE Connect, as we showed here in the model that is the wooden model, you can also delete the nodes here. Okay, you can delete the nodes and leave just the nodes you are working. So imagine that this list that was imported in the beginning, if I am the professional number 1, I can delete those that are not mine, and then the second do the same, the third do the same, and then each node that we create, we export to the library, and then we can import again in the end at StruBIM Steel and finish the model. Okay, this is just an idea. This is just a tip, a good practice you can do in a different way. But the purpose of the seminar was giving tips, and this was one of them. Okay,